One, 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 two, three. Okay. Thank you, everyone, for coming to my presentation. When computers were big, ZOS penetration testing workflow. My name is Denis Stepanov. I am senior penetration testing at Kaspersky Security Services. I have some fancy security certificates. Sometimes search the bugs, and also sometimes research some interesting things like mainframe. And yeah, I divided my presentation on the two parts. The first part dedicated to penetration testing workflow for mainframes, IBM mainframes based on ZOS. I will talk you about some interesting features of the mainframes and some interesting behavior of the well-known services which may help you to compromise mainframe. And the second part dedicated for security package resource access control facility, or shortly RACF. Some features, structures. Also, I will introduce our tool for more detailed investigation offline for RACF database, and a few words about password caches. Yeah, before we start, don't be afraid unknown terms. Look at this like on the guide. And I made some mind map, and you may use it in the future when you will face it with the mainframe. Yeah, a little bit disclaimer. All themes are related to RACF based IBM mainframes, and the most technical, well-known, and you may find it on the internet. Yeah, let's start. Some brief ZOS overview. If you don't know what is ZOS and what is a mainframe, you may look at the pictures. It's some big computers that most commonly used for large-scale transaction processing. And ZOS, it's a system, it's an operation system for such devices introduced in 2000 years, and it has some components, it's a modern operation system. Particular, it has some Unix subsystem, and Unix subsystem allows to work with some modern programs like the WebSphere. It supports Java language and DB2 database and so on. But also it preserves the old principles of the operation defined in the more years ago, in 1960s years, and maintain backward compatibility. This system is rarely presented to the customers. I think it's the main reason it's a narrow focus and the high cost, and also I think it's a main reason of the small community and the penetration testing of the mainframe. And if you're looking the first time mainframe during penetration testing, you may spend a lot of time for gather all information about it and understand it before try to compromise mainframe. And I will try to decrease threshold to enter in this theme. And yeah, I will focus on some unusual features, the unusual behavior, and let me start from the recon phase. So in other words, how to understand what you're facing with the mainframe. The first region may be some unrequired set of the TCP ports. Pay attention on some unusual ports of FTP and Telnet. Yeah. And the second region, it's banners of such services. It may contain some keywords like the ZOS, the mainframe, and IBM, and so on. Yeah, here is very convenient feature of the standard Telnet service in the mainframe. It's answering whether user access to login in mainframe or not. And as you may see, you may perform some user enumeration abusing this feature. And also, such technique is well known. You may use some tools for like the potato or nmap scripts for perform user enumeration. And sometimes knowledge of the valid username may be enough for initial access getting. If you have some specific username, you may to use some chains username equal password. Also, you may face with some chains with the default password of the standard user. It is not rare, and I think that the main reason of such mistake it's a weak password policy by default. RACF support two password-based authentication methods. The first is a password. The second is passphrase, and as you may see, the password has a really weak password policy, length less than 9 symbols, contained also uppercase and digits and a few special symbols. And such gentle password policy often is used by the system administrator to use some really weak password. And in the future, I will show you some details about the passwords. Also, you may perform brute forcing, but pay attention about account locking policy. You may use also potato nmap scripts for brute forcing users, and it's a good choice for brute forcing users who make to logging in mainframe via the password. But what about passphrase? We found only the one way for successfully brute forcing. It's abusing IBM HTTP server, and for it you may use any tools which support HTTP basic authentication. And for example, Hydra. Yeah. The next phase it's execution. Regardless whether we got valid user credentials on the previous steps, there are a few ways for execute command into mainframe. Yeah. The first it's abusing job entry system. Job entry system it's some system. It's some subcomponent of the ZOS that receives some task, execute them, and output the result. And the distinctive feature of job entry system, shortly JES, it's that FTP may be interfaced to interaction with it. And in the future slide, I will show you how you may to abuse that feature to create, for example, bind or reverse shell. Also, subcomponent of subcomponent, it's a network job entry. It's a subcomponent of JES that allows to communicate communicate mainframes between each other over the network. It may share some tasks between each other, but such thing is more complicated. We will not consider it in such presentation. The next thing, it's abusing or managing some applications or resource managers of the mainframe via VTEM. VTEM, it's a virtual telecommunication access method. It allows you to communicate with the mainframe's application over the network. For example, TSO, time sharing options, resource manager via or to application like the Kix. Also, you may use standard services like the Telnet or FTP for connection to the mainframe and manage it. And the last thing is abusing or exploiting web applications. And in the future slide, I will show you some examples. Let me consider process of execution of the mainframe. Here is how JES works. It receives some input task in the various formats, for example, in the job control language, GCL. After that, it's executed, and result will be output into some place. And yeah, on the practice, following these steps may help you to execute command on the mainframe using the job entry system. Firstly, you need to connect to FTP server with the valid user credential. After that, you need to upload some special compile at netcat. It may be found on the internet. After that, you need to switch current FTP connection to some special JS mode. In this mode, job entry system will take all uploaded files like jobs, like some instructions for jobs, and you may use a GCL batch file for execute previously uploaded netcat, for created bind shell or reverse shell, and the final step, don't forget to catch this shell. Also, such technique is well known. You may use some Metasploits module or some scripts from the GitHub, developed by Mainframe. It's a really good choice. Okay, moving on to the next method. Such method is more classic. In 1970s years was used some computer terminal to communicate with the mainframes via TN3270 protocol. But if you have not such device in your pocket, you may use terminal emulator. Here is an example of working with the terminal emulator X3270. Such terminal emulator allows you to perform connection to mainframe via TN3270 protocol over the telnet. Yeah. After successful connection, you may choose any application or resource manager for interconnection with it. Yeah. Here are some examples. Time sharing options. It's and interactive system, productivity facility, TSO and ISPF. TSO looks like the command line. ISPF looks like graphical user interface. Functionality of those resource managers are very similar. You may use one or another for managing mainframe. And I will focus on the TSO commands in the future slides. Here is an example of connection to standard internet service, and after connection you will gain access under Unix subsystem, which named Unix system services. And here is an example. You'll gain access to managing some ZOS Unix shell. It's like the bash or SH. It's more comfortable for managing it. What about web application? You may use well-known vulnerability of IBM HTTP server and exploit it. And also you may face with some custom application, and you may try to find some ways for remote code execution via, for example, code injection or some insecure file upload and so on. Yeah. After gaining access under the mainframe, you may escalate your current privileges. And before considering privilege escalation, let me focus on some access control system. Yeah, here is when users try to gain access to some resource, system authority facility requests some resource package. Security package. Request some security package, and security package often have some information about user, permissions, privileges, ZOS support, few various security packages, but I will focus on the standard IBM security package, resource access control facility. Yeah, and after user successful login in mainframe, its user profile will paste from the RSAF database to RSAF service memory. And the most popular method of the privilege escalation is to find the way change change such user profile in the receive service memory, but it is not all methods. Yeah. Here are some ways for compromise for privilege escalation in the time sharing options. The first is the dataset access control misconfiguration. Dataset in the mainframe, it's file. It may contain some text information, some information about some scripts or program, and some data for applications, maybe. Yeah, and such data set may have maybe marked as authorized and program facility, or shortly APF. APF, it's APF may if data set it's APF, it may to perform some privileged actions during runtime. For example, access to some resources, to some memory, and so on. For example, if we have enough rights, enough permissions for changing some data set, you may to paste some code that will find in the RACF service current user profile and change some bytes for escalate current privileges. Yeah, the next subtype, it's warning mode. Warning mode, it's yeah, interesting feature of the mainframe. This mode allows to get access under dataset for with the maximum access rights for any user in the mainframe. But during access appears some message that system administrator will be notes about such access attempt, but it also allows to perform any actions. And yeah, such distinctive feature of the data set in the warning mode. And for example, maybe some misconfiguration when the sensitive data in the warning mode, and maybe some APA file in the warning mode, and you may abuse it. Also, the second way, it's binary exploitation. It's also very complicated theme, and I will not consider it in such presentation. There are some well-known vulnerabilities of the services, and you may abuse it. And the last thing, it's misconfiguration in resource classes access control misconfiguration. Resource classes in the mainframe, it is some entities that defines class of the privileges. For example, class for some privileges for the user management, for storage management, for Unix subsystem, and so on. Yeah, and in the future slide, I will show you some examples. Yeah, what about data set? You may to enumerate all data set in the warning mode using such command in the TSO. And what about APF? You may also use command in the time sharing options for perform enumeration, but have the another ways using scripts from the GitHub. And after finding some interesting APF with the corresponding rights, you may to exploit it, also using Metasploit module or scripts from the GitHub, elv.apf. But pay attention that during runtime, such script performs some persistence. It adds current user to some privileged group, sys1, and thus it changing some RCF database. And if you don't know to change RCF database, you may use script in the same GitHub repository, that will impersonate already logged on user, some privileged user, and yeah, thus to escalate your privilege. Few words about resources. As I mentioned before, resource class consists of some resources, and the certain resource defines certain privilege. For example, bpx.fileauthor.apf allows user to set up APF flag under the some data set. And also, any resource may contain some list of the access authority to some user. Access authority defines some access right. And in more cases, it's enough to read access authority for user having such privileges. And it is not obvious. For example, I think that I thought that if I had the read access authority under the such resource, I made list users who have the such privileges, but not. If you have the read, minimum read access, you have such privilege. And how you may to abuse it. Here's some example of enumerate and abusing TSO out resource in TSO out resource class and resource test out. If you have a real access authority under this resource, you may to execute our data set as APF. Yeah, only by running it. Resource with the mask mvs.setproc.** allows you to set up APF to some data set, and using previously exploit script from the abusing APF, you may also escalate your privilege by such resource misconfiguration. The next interesting resource class is a facility. Facility contains some interesting resources. It is not all list, but many interesting. Some, for example, err.password.reset resource allows you to set up to reset password for some users, users without some special attributes like the special, like the operator, operations, like the auditor. And the second, it's a bpx.superuser. Such resource allows you to log in Unix subsystem like the root. Here is the example. You may enter in the time sharing option such command omvs. Omvs will run ZOS Unix shell in terminal, and after that you may enter su root, and you may gain access root under the Unix subsystem. Yeah, the last interesting resource class is a surrogate. Surrogate allows you to impersonate any users in the various subsystem of the mainframe. For example, if you have the resource with the mask bpx.adm.some user ID, you may to impersonate such user in the Unix subsystem by running su with the flag -s. And the second interesting resource, it's had the mask user ID.submit. You may such resource allows you to impersonate user in the job entry system. In other words, you may to run some job from another username. Also, you may to escalate your privileges in the Unix subsystem. As I mentioned before, command omvs runs ZOS Unix shell for switching to another context. And Yeah, you also may use SU utility. You may find some SUID and GUID bits on some utilities. There is interesting script that may help you to find some unusual features of the certain mainframe configuration, and you may face with some interesting files, access to some interesting utilities, and so on. And the last interesting thing, it's utility xutter. Xutter with the flag plus A allows you to set up APF flag on the some Unix file. But Unix file, it's also dataset, but another format. It may be format some HFS, hierarchical file system, or ZFS, ZOS file system, but it also dataset. And here's example how directories and how files of Unix subsystem stores in the dataset format. And thus, if you may set up some file, if you may set up APF flag under the some file in the Unix system, you may find it in the time sharing options resource manager and escalate current privileges and time sharing options. The last things about privilege escalation, it's exploring a NetView service. There is some certain version of such service, and you may use also exploit for escalate your current privileges. Okay, moving on to the next phase, it's collection. Such phase may be useful when mainframe, it is not your main goal during penetration testing, but you may find some interesting things in the files inside. Here is examples, some unusual parts for shell history location, and some Kerberos and LDAP config and config to other ZOS services. And for example, WebSphere. Also, WebSphere may contain some credentials for LDAP, for databases, and so on. And such credentials may be easy to decrypt. You may use such script for decoded. These credentials may be useful for reusing it in the current mainframe or for lateral movement and so on. Yeah, the same story with the LDAP password. In some cases, LDAP password may be stored in some special stash file. Here's example of creation such stash file, and also it's easy to decode, to decrypt it. Yeah. The final phase, it's exfiltration. You may exfiltrate any data from the mainframe via some standard services, FTP and SSH. Also, terminal emulator X3270 may help you to exfiltrate data. And some dirty trick, it's copy your data to web server static folder. A few examples about exfiltration datasets. More comfortable, it's via X3270s, terminal emulator, or via FTP. When you connect to a FTP server, you gain access under certain user datasets. But it is not a bad idea to check some path traversal and to gain access some sensitive data like array save database. And also you may to convert some Unix file to dataset. Also you may use exfiltrate Unix file. Here is example for conversion some dataset to Unix file. And for switching context in FTP connection, you may to change directory to some place in the Unix directory. Yeah. The second part of presentation is about RSAF. The previous examples were about exfiltration of RSAF database, and I think that it's one of the most important data set in the mainframe. Regardless how you got RSAF database, via wrong data set access control or via privilege escalation, analysis of RSAF database will be very useful for lateral movement and for privilege escalation. And we noticed that investigation of such database may help you to find some unusual ways and not obvious vector for mainframe compromise. Yeah, a brief overview, as I mentioned before, RSAF is a security package that controls user access to resource, perform authentication and auditing. Information about users stores in the RSAF database, like the user profile. But what about RSAF database? All entities about ZOS stores in RSAF database as some profiles. Yeah, and here is example of the 4 main profile types. User profile type contain information about user password hash, user special attribute, and so on. Group contain information about groups, subgroups, and members of such groups. Dataset contains information about permission to dataset, audit policy, special attribute like the warning mode, and the general profile contains information about resources and resource classes. Yeah, each resource profile consists of some unique set of the segments, and each segment contains an unique set of the fields. For example, user profile contains base segment, and base segment contains password field, and password field stores user password hash, for example. Yeah. Database of RSAF, it's internal part of the mainframe. It's a dataset. It's a dataset of the some certain structure, and for future investigation, for future analysis, more interesting blocks of such structure. It's a header. Header contains some useful metadata of the RSAF database, and also it has some pointers to the other blocks of such structure. The next interesting structure, it's index blocks. Index blocks contain information about all profiles. It's a one-way list with the pointers to all profiles of any types in the current RSAF database. Yeah. The last interesting field, it's a template. Template contains information about templates contain information about all kind of templates for of kind of no. It contains information about profile types templates because profiles in the index block stores like the raw data without structure, and we need to perform some parsing. We need to know some structure of certain profile type, and template describes such structure. Yeah, and we would like to perform more detailed analysis of the RSAF database, but existing tools perform some partial analysis, for example, extract some some password caches, and required to works by running it on the mainframe in the runtime. And we developed our own tool for receive database investigation, and what's how we approached. Yeah, parsing header, we extract all profiles. After that, we extract templates for all profile type, any profile type, and prepare it. And after preparing it, we parse any all profiles with the corresponding profile type template. And as a result, we paste it into some SQL-like database. And let me introduce RSA Fudit. It's written on the Golang. It's a version independent because if the in the future version of the RSA database maybe change some format of the some profile type, we will know about it, and we will parse in the right format. Also, we have the plan to integration with the Neo4j, and in the future slide I will show you why. Here's some use cases of using such tools. For example, we made to extract password caches of the some system administrators because we know that system administrators are members of the SIS1 group. The second case, it's searching dataset universal access authority misconfiguration. Universal access authority in the dataset, it's some default credential, or default permission for all user in the mainframe, and it may be dangerous if universal access authority is high. Investigated RSA database, we face it with some interesting property of the user's attribute group special. Here's an example. If the user had the some special attribute group special to some group, it means that group access authority extend user access authority. For example, group 1, user 1 had the group special to user 1. User 1, it's owner of the user 2. Oh, excuse me. User 1 had the group special to group 1. Group 1, it's the owner of the group 2. Group 2, it's the owner of the user 5. Thus, user 5 in the authority scope of user 1, and user 1 may perform some privileged actions under the user 5, for example, reset password, regardless have the user 5 some special attribute or special operator, auditor. Yeah, and such misconfiguration is not obvious, and we found a lot of privilege escalation vectors by investigated RSA database using RSA Fudit. Yeah, thus we see that between any profiles maybe some relationships, and we may build some chains of such relationships. And based on the attributes, you may to define some high privileged user or low privileged user, and more interesting to build the chains for searching path from the low privileged user to high privileged user. And yeah, you know that I know you know. I think you know the same tool, Bloodhound. Yeah, this guy had some huge community, and It helps to searching Active Directory misconfiguration. But what about RSA audit? It only begins your development. And what now we have? Yeah, we have that between some profiles, maybe some relationships, and based on these relationships, we need to build our chains. Here's examples of the chains. Test user has a group special attribute under the group pass ADM, and pass ADM is the owner of user operator. Thus, test user may reset password to operator. The next, operator allow read to error password.password.reset resource, and we may to reset password to DFS oper user, and such user have the privileges for enter in the Unix as a root, for example, with a UID ID. Yeah, it's the first chain. The second chain, it's test user allow read to some surrogate class and resource oper sms.submit, and thus it may to impersonate oper SMS user. Oper SMS user is a member of HFS admin group and touch group. Allow read to test out resource, and we may run our dataset as APF, and you may to escalate our privilege. Yeah, here's a few examples. Such chains was built manually via SQL request to SQLite database after RSA audit works. And this is the main reason of the integration with Neo4j. I think that after integration, we need to automate our process of building such chains. Yeah, and a few words about hashes. As I mentioned before, there is the password-based authentication methods via password and passphrase, and also it may be stored by encoding of the few formats via DES algorithm, and the new algorithm KDFIS. It's some IBM custom algorithm based on the PB KDF2, and yeah, let me consider algorithm DES for the hashing of the password and the passphrase. For password user, it's clear text. Password, it's a key, and result, it's result of encryption. It's an 8-byte hash, which is stored in the password field of user profile in a RSA database. But what about passphrase? Its algorithm, it's unknown. We know that it's based on the DES, but also we note the hash corresponds some length on the passphrase, but also we note that if you will give, we note that you may use the first 8-byte of the passphrase passphrase hash for brute force it like a simple password, and for example, you may to guess, if length of the passphrase is a 10, you may to brute force perform offline brute forcing for the first 8-byte, and we'll try to guess the rest of the passphrase. For example, if you after offline brute forcing we got admin 1 to 3, maybe the full passphrase admin 1 to 3 4 5, for example. But what about KDFIS? It's more complicated. It's divided on the few parts, and after performing all encryptions, we may the first 8-byte concatenate to the PVCX password field. Another part of the password paste to the password field. And we also developed hashcat script for performing brute forcing of such hash. But what about passphrase for KDFIS? It's really more complicated, and we don't know exactly how it works. We understand that the first phase it's some custom algorithm SH. So 256, but exactly we don't know. That's all. Here's a reference to RSA audit tools and for ZOS mindmap, and here pull request for hashcat for brute forcing KDFIS password hash. A special thanks to my colleague Alexander Karotin. He's main developer for of the RSA audit, and that's all. I'm ready for question. Thank you.
When you decided to implement your own tool for ACF database parsing, was there nothing else public available that do that job? Okay. When you decided to develop your own tool for RACF database parsing, were there no other tools publicly available for doing that job, or why did you decide to make your own?
Excuse me.
Okay. Can you hear me? Okay.
Yeah. Now, when we developed our tool for RSAF database parsing, the next part.
Yeah, when you decided to do that, was there nothing publicly available for doing that, or why did you decide to make your own?
Yeah, we make it our own before because because existing tools perform some partial analysis, and we would like to more detailed investigate RSAF database, for example, by sending some SQL requests for any fields, for searching some interesting field, because it is some internal part and of the IBM, and IBM close transparent access to some internal some internals of working of its services, and we would like to look inside and to see maybe we may find something interesting inside of RSAF. And no, our tools is not based on the some another tools. It's own implementation, and I answered it on your question.
Yeah, okay. Existing tools are good enough, basically.
Existing tool.
Well, basically, so decided to make something more complete.
Excuse me. May we are ending, and in the couloir, I made to answer on your question.
Okay, thank you.
No. Yeah. Okay, thank you. Please don't forget to stay our feedback for my presentation.